Hello everyone, in this video we'll see binary trees diameter of the tree. This question is more frequently asked during the programming interviews. Your task is you are given a binary tree and you have to find the diameter of the tree. The diameter of the tree is in the sense which is the longest path in this tree. Here we have the node definition of these nodes. It contains data and right and left pointers. In this tree you can see this is the longest path. Namely, you can see this is also a longest path, but the number of nodes actually counts. Here you have 7 nodes at most. Here you can 1 2 3 4 5 6 7. So if you count this one also, it is 7. 1 2 3 4 5 6 7. So you have to print the answer as 7. That's it. Wherever you count, here it will be 7 only, but this is for perfect binary tree, so that's the reason you are getting the same answer throughout the tree. But that's not the case when it covers all the trees. So here I have one code snippet for finding out the diameter of the tree. It expects 2 parameters, namely node, which is the root node it expects, and the one tracking variable called max. Inside this function body, if the node is null with incoming node which is coming in this first argument, if it is null, so we have to just return it. So nothing to do with that. Okay, now I have to go to the left side and go deeply in the left side, and I have to do some operations. And similarly, I have to go to the right side also, and I have to do some operation. And when I'm going to the left and right, I'll returns with some values what's the height of it. So I'm adding these two height plus 1. So here I have 2 and here I have 2. So along with this root plus 1. So I have to make the addition, and I'm updating that max variable. And for returning just the height of it, I have to find the right and left, which is the maximum, and plus 1 I have to return it. So our answer will be in the mx variable, not from this return alone. So we have to print this mx variable. That's what carries the answer. Okay, now we see this an example. Here I have 10 20 like that until 70. Here I can see this is a longest path. You can say this is also, but you don't need which path it is, but just to print the answer. Okay, now my task is I'm starting with the root node. So 10 is there, it goes to the root node, and mx variable, I have the reference of this variable in the main function body, so I'll pass the address of it. So this max variable starts from 0. Okay, now it goes to the first line, and if the node is null, it returns 0, but it's not the null node, so it goes deeply to the second level 20, and again it goes to the 40, because this recursively it calls until it gets as a null, and here it is null, so no nodes are attached with this one. So what it do is, here it is update this max is left and right, it is 0, so plus 1, and max variable. So here mx variable will be updated as 1. So what to do is 1. Okay, now once it's 1 is there, it will expect max right and left plus 1. So my height is returned. So what here it is returned is height. So 1 is returned. Similarly, you have this right side travel, and it's supposed to return that height as 1, and then moreover this operation is similar, so the 1 will remains same when it encounters this 50 also. So when it comes to 20, here you have written a statement max of left and right plus 1. So here we are adding 1, this one and this one for this node. So there are 3 nodes are there. So this is one path. So this height and the right height, left height plus the current node. So 1 1 1, so 3. So what I have currently is 1, so this statement will update the max variable as 3. Okay, now it returns the height. So here 1 and this height 1 plus 1, here it returns it as 2. Here it is 2. So when it goes to this left side, the same operation, it straightly goes to 60. It returns 1 1, and here this returns as again it will add up and makes that variable 3, but it is not greater, so 3 will remain same, and this 30 will returns the height as 2. So here we have 2 and here we have 2 along with this 10 node plus 1. So the left and right plus 1. So left 2, right 2 plus 1. So it is 5. So we got the answer. So we'll update that variable also here to 5. We have to print this reference, and here also I have the same tree, but here some of the nodes are missing. You can try this and you can get the answer same as 5. Okay, now here you can see a weird version of this binary tree. Here whatever we have done so far is goes via this root node called this 10. But if you see in this one, the 10 is the root node, but here nothing is there at the right side. So what we do is we have to see the whole tree, and we can see this. This is the here. This is the path where the actual answer is. So here is the answer. You can say this one also, but this is the answer. The answer is 9. Here in the first line, I have just written the post order traversal of this binary tree. So with this post order traversal, you can understand which node will be visited first. So what here, when it comes to directly here, it comes directly to 90. So that's what this 90 is. So what we do is here, this same approach what we applied earlier, the above tree. So here it is 1, so here it is 1 height. So when I include this one, the max will be 3. Here left and right and addition of this one, so it is 3. Okay, when it comes to this one, you can see this after 90, 100, 60, and then it is 40. So when it comes to 40, you can see this in the left side nothing is there, and here you can see this height plus 1. So there are 3 nodes, but it is not greater, so it will not update. So it go upward and directly comes to this 70. So 70 is just returns 1. So my here it returns 1 only. So it comes next to directly this 130. And I hope you can see this in the post order traversal. So after this 70, it directly comes to here. Okay, now when it comes to this 130, this 130 returns 1, and this 140 also returns 1. Here it is 3. So it checks here because this 1 and 1 plus 1, so 3, and it goes upward. So this pass with the height, so it is 1, 2 and 3, nothing is there. Here it goes, so what here it is 4. You can see this 4. So I have to update this node as 4. Okay, when it goes up, you can see this 4, and it returns the height, so it is 5. Okay, now again it checks and it will update it as 5. Okay, now it adds this, so you can see this 1 2 3 4 5 6. So when I'm node 50, you can see this answer, you can see it as 6. I update it as 6. Okay, here it is 6, but what it returns, this 50 returns is just the height. So 1 2 3 4 5, so 5 only goes here. Okay, 5 goes. Likewise, similarly in this one it returns here 1 2 3, so 3 returns. So when I'm adding these two, 5 and 3 plus this one, so it is 8 plus 1, so 9. So 9. But when this 30, what it returns is just the height. So what's the height here is just 6. Here it goes as 6. And what this 20 does is just returns the height, so it takes us 7. But in this iteration itself, you can see we already got the 9. So what tends to have is at most 1 2 3 4 5 6 7 8, but our actual answer is 9. This is how the inclusion and the exclusion of the root node comes when the diameter works. Okay, we just seen this diameter of the tree. So what we do is we quickly jump to Visual Studio Code, and we'll write this code and execute the results for these 3 trees. Okay. Okay. Here I have a basic setup. Here you can see some include statements, necessary include statement, and here I have class node definition, which carries this data and the 2 pointers, namely right and left. And in here in line number 9 you have constructor, and in the main function body you can see this 3 trees written in the code format. This tree, this is the second one, and this is the third tree that you can see in the coded format. So I directly write this code. So what I do is int diameter, and it expects the node, so node root, and you need a reference of the variable, so mx. If the node is null, I have to return 0, and I have to travel at the right side and left side. So what I do is int left height equals to diameter root left comma mx. Same thing for int rh equals diameter root right comma mx. Okay, now I have to update my mx. So mx equals max of content of mx comma lh plus rh plus 1, and I have to return max of, I have to return just the height, so lh and rh plus 1. Okay, okay, now I have these trees. I just create one more pointer called p. With this I have to go n diameter, and I have to pass this node n and address of p. In cout you can print this p. Similarly you can give the same thing for m3 also, and I can make this p equal to 0 here. and y. Okay, just 4 5 lines. If the route is null, so you'll return, and you have to travel at the left side, and have to take that left and right height +1, and you have to update this max variable and have to check. Okay, the same snippet code here, which we have written here. So we'll initialize this p as 0, because first time it is how to initialize this. So we have to write that p equal to 0. So okay, my code is ready. I'll run it. So 559. So here also you get the answer 5 5 and 9. So all the test cases are executing perfectly. Hope you understood the problem and solution. Thank you for watching this video. We'll meet in the next video.